Hey everyone, today we're going to discuss section 4.3. This is on logarithmic functions. Let's go ahead and look at an example. A population of 50 flies is expected to double every week, leading to a function of the form f of x equals 50 times 2 to the x, where x represents the number of weeks that have passed. When will this population reach 500? Well, if we try to solve this problem, we get 500 equals 50 times 2 to the x, right? We have 500, which is our final amount, is equal to 50, which is our initial amount, times 2, because we are doubling every week, to the x power. If I divide both sides by 50, I get that 10 is equal to 2 to the x. So what can I do here to solve for this x? I see that there's an x in my exponent. Now, using a bit of prior knowledge, I might say, well, I know that 2 cubed is 8. I know that 2 to the 4th is 16. So I know that if 2 to the x is equal to 10, then x has to be somewhere between 3 and 4. But this isn't necessarily super helpful. I could also graph this. I could graph 10. I could graph the line y equals 10, and I could graph the curve y equals 2 to the x and find where they intersect. But that's not super satisfying, and it doesn't necessarily give us an exact value. So none of these functions that we've discussed serve as an inverse to the exponential function. So we're going to introduce a new function called a logarithm that is going to be the inverse of an exponential function. Because exponential functions have different bases, for instance, 2 to the x power has a base of 2, logarithms will also have different bases. So we have a few definitions here. The logarithm base b function, written log base b of x, right? Again, this is read. Let me type this out here. This is read as log base b of x this is the inverse of the exponential function b to the x power. Because the logarithm and exponential are inverses, it follows that log base b of b to the x, notice how my logarithmic base and my exponential base match there, is equal to x. Those things undo each other. Similarly, it's a little bit difficult to see here, but this says b to the power of log base b of x. So it says b to the power of log base b of x is also equal to x. I know this base b is a little bit difficult to see here. Notice that on logarithms, my base of this logarithm is written as like a subscript. It's slightly below the rest of the line. Also, the statement b to the a power is equivalent to the statement log base b of c is equal to a. And we can see this if we write this out, b to the a equals c. And then if I take log base b of both sides, the logarithm is a function. I can apply this function to both sides of an equation. Let's see, log base b of b to the a is going to be a, right? That's going to be from this first property of logarithms. So the left-hand side is going to be a. And this is equal to log base b of c. So log base b of c is equal to a is equivalent to the statement b to the a power is equal to c. Let's look at some examples. Write these exponential equations as logarithmic equations. Let's see, for the first one here, 2 cubed is equal to 8. If I take log base 2 of both sides, this is log base 2 of 2 cubed is equal to log base 2 of 8. Log base 2 of 2 cubed. Notice how my exponential and my logarithmic base match on this left-hand side. That means I'm going to be left with just what was the exponent. This means 3 is equal to log base 2 of 8. For this next one, I can take log base 5 of both sides. This will become log base 5 of 5 squared equals log base 5 of 25. Log base 5 of 5 squared is 2 because my exponential and logarithmic bases match. This is equal to log base 5 of 25. And for this last one, I take log base 10 of both sides. So I have log base 10 of 10 to the negative 4th is equal to log base 10 of 1 over 10,000. So the left-hand side I have negative 4, and on the right-hand side I have log base 10 of 1 10,000th. Now, let's look at going the other way. Write these logarithmic equations as exponential equations. On the left-hand side, I have log base 6 of the square root of 6 is equal to 1/2. The way that I undo these logarithms is by exponentiating with this logarithmic base on both sides. So, my logarithmic base here is 6, so the base of my exponential function here is going to be 6. So I'm going to take 6, and I'm going to raise it to the power of the left-hand side. And this is equal to 6 raised to the power of the right-hand side. Because on the left-hand side, my exponential and logarithmic bases match, I'm left with just what's inside of that logarithm. It's square root of 6. This is equal to 6 to the 1/2. And b, the base for my exponential function is going to be 3. So I'm going to exponentiate both sides with this exponential base of 3. So on the left-hand side, I have 3 to the log base 3 of 9. This is equal to 3 squared. On the left-hand side, because my exponential and logarithmic bases here are the same, I'm going to be left with just what was inside of that logarithm, which is 9. This is equal to 3 squared. And of course that's true, right? Next up, solve log base 4 of x equals 2 for x. Okay, so how I can do this is by rewriting this as an exponential function. So that is log base 4 of x equals 2. Maybe I'll rewrite that. It's a bit difficult to see the 4. What I want to do is take this logarithmic base. This becomes the base of the exponential function, right? And I'm exponentiating both sides here. So I have 4 to the power of log base 4 of x is equal to 4 to the second power. This leaves me with x on the left-hand side, and I have 4 squared on the right-hand side. 4 squared is 16, so x equals 16. And for example 4, I have solve 2 to the x equals 10 for x. Okay. Well, I can take log base 2 of both sides. On the left-hand side, log base 2 of 2 to the x gives me just x. And on the right-hand side, I get log base 2 of 10, which is going to end up being some number. This is an exact solution. And in fact, in not too long, we're going to look at how we can find this exact solution in our calculator without having to use any special buttons hidden away in menus or anything. This is going to be it for the first video. There will be probably 2 more videos for 4.3.